Hello and assalamu alaikum everyone. Last time we discussed the constant data members, and in the constant data members we discussed that sometime we need some variables, and we want these variables to be restricted so that no object may modify that. For example, in the case of the student, if we are going to develop an application for the university, and these are our data members, then because all the students belong to a same university, so in that case we will need that university name shouldn't be remain the same, and object shouldn't be allowed to change that. Exactly, if you deal some mathematical problem, then you can observe that the value of pi usually remain the same, 3.14, and in that classes we will keep that data static. Or if you are solving any physics related issues, then the value of g is remain constant, and we will not allow the objects to change these values because these are universal, and we need that to be constant. In such a cases, when if anything is constant, then the same values will be copied to the object, and we will not allow any object to replicate it. For example, if we have allowed, then the university name should be UOS, then every object should have that, only the UOS. They will not be allowed to use their own terminologies. As you can see over here, that someone is writing as UOS, someone is writing US, someone is writing Uni of Srigoda. So we will not allow this practice that anyone can write according to the requirement, or object is changing it, object is writing it. So what we can do for that, to handle that, we use the keyword constant. When the constant keyword is used for that, the object would not be able to change that. We will define it over here, we will initialize it over here, and after that object will not be allowed to change, and this same copy which we defined over here will be copied to everyone. And we observed the same behavior in our program, that it was exactly working as we discussed over here. Now today we are going a bit further. We will discuss the static data members. The static and constant, by the keyword you can say they look very similar, the static and constant, but they are completely different. Their working is completely different. So let's see, for example, you have developed one website. It is enterprise level website, it's on the cloud, and the people around the world are visiting that. And what you do actually, that you are recording the visitor, that there are a number of visitors who are visiting your website. So what you want to do next, that you display here one label, and in that label you show that how many visitors are online at that time. So if there are n visitors or 1000 visitors, this will be shown to the user 1 also, this will be shown to the user 2 also, user 3 also, and user n or 1000 users also. So it means that this is the value which is a part of the object, which the object is able to see that. But if you see that the value is same for everyone, because in that case we are showing the total visitors. You can see over here that we created object here for the users, for the visitors, and in the visitor 1 you can see that the total user count is 1000, because total 1000 users are connected to the website. In the user 2 you are observing the same user count, in the 3 you are observing the same user count, and similarly in the nth user, which is 1000, there you can exactly see that currently 1000 customers or users are connected to that website. actually what happening here, what is happening here, and what are the things which are going towards the bad behavior of the programming. You can say that this value is same for every object. This value is same, because if the 5 users are online, they all will get the 5 value. If the 1000 users are online, they will get the 1000. If there are millions of users, they will get the 1,000,000. So the value is same for everyone. But the issue is that the object 1 is needing its separate space for that, 2 is also needing a separate space for that, and if there are millions of users, the millions of users will need a separate space for that. So if this is a cloud website handling millions and billions of people, millions and billions of users, so for everyone you are providing the space to a value, which value is same, which value is common for one. Everyone is getting the same value. So instead of wasting that time, instead of wasting that memory, instead of wasting that computational power, what we can do, that we can share that value from somewhere from the classes. We can share that value because this is common to everyone, and we can share that to all the objects. So what we can do, we can create one shared memory. Now that memory is not part of the object. Now you can see that we haven't defined that memory, the user count here at the object level. We have defined this shared memory. You can say that this shared memory is now part of the class, and we share the same memory. We are just sharing the same memory with all the objects. So this data is not stored at the object level. This data is stored at a class level. This data is stored at a shared place, shared location, instead of storing the same data for every object. Definitely, if we store that data at a single place, at a shared place, instead of storing separately for all objects, definitely it will save a lot of memory, it will save time, and it will increase the performance of the system. So for that, in such like cases, we use the static data members, and it is shared with all the instances, all the with all the objects, and no object is going to store its copy. So this was the basic introduction. What is actually a static data members? Now let's go starting its practice and check its behavior, check its observe its behavior, that how actually it works when it is coded. So now I'm going to include the header. This is the same header we use every time. This is my main function, and the program is static. I will also share the detailed programs with you also on the tutorial. You will be able to visit that from there. We once run that to check the behavior. So now we are going to code a class for that. So my class name here is counter. I'm using a counter class here because as per our this example, we are actually counting the online users. For the online users count, I'm writing one class counter, and in that class I will define one static data member. This is a public, and in the public I need one static data member count. So count is a data member, it is an integer value because we are using the count as a mathematics. We will add and subtract the values. So this is the reason it is an integer format, and its data type is integer. And we are also using the keyword static. Keyword static means that for the count, separate space will be allocated. A shared space will be allocated for that. As you can see over here, that a separate space is allocated to the user count. Exactly over here, after writing the static, a separate space will be allocated to that. I will also need one show function to show that value. And in that I want to show the users which are online. Online users are, and after that I will show its value, which is count, and I'll for the new line. There's one thing which we need over here, that to handle the static counter we need the static function also. When you declare that count as a static, it means that the object is not going to have any copy for that count. This count will belong to the class, this will belong to the counter, this will belong to a shared space. And here what you are doing, you are using a void show function, and in that show function you display the count data. But this will not work for that, because counter is a part of the counter, it is shared memory, and the show is a part of the object. This show function can only show the data members which are part of the object, but count is not a part of the object. So what we can do over here, to handle the static member, we use the static functions also. Now this function is also a part of the counter, not the object which we will create for the counter. So in that case, here the static will be able to access that value. So what we should do next, in the main we are going to create its object, as we are needing a users for the website, but in the static, as we discussed, as we defined that this static data members will belong to the class, this will not belong to the object. But in the definition we have also studied that the class is not going to store any data. Classes are just instruction, these are virtual, these are design. It is not going to have any space on the memory. So what does this mean, static then? And that the count will belong to the counter now, the count will belong to the class now. For that we actually defined a shared data space, and that shared data space will belong to that class. We will link that share space to you can say to the counter class, as we have defined over here that this is the count. So out of side of that class we will assign value 0 to the count. So within the class we just define that, and outside of the class we are going to initialize that. But currently this shared memory space is not linked to the class counter, and to link it with the class counter we can write int counter is class name, scope resolution operator, and after that the count is the data member, which is actually a static which we have declared as a shared data member. So now you can see over here that we have a counter class, and in that counter class we have one count a static data member. Because this is a static data member, it means that we have declared that as a shared space. Because that is a shared space, that we need to create one shared space over here to share that data with all the variables, to all the objects. And similarly, we wrote here one static function also. Why? Because if we don't declare that show function as a static, that show function will belong to the object, and the value is not belonging to the object, so the simple function is not going to show that value. Therefore, I use a keyword static over here. I declare the show function over as a static, so it will work for the static data member. So let's go, and here what can I do? I create one object for counter. I think we use the counter as a class. Yes, counter. For counter, I am going to create C1 objects. So this is the one object C1 which we have created for the counter. What is the error? And then okay. We need another thing too, because as the C1 is created, as the object is created, this value should be incremented. Now you should think that what programming functionality which we can use for that to counter, to increment the 0 on the object creation. So you should remember that we studied about the constructor, and we discussed the same in the constructor, that anywhere when we need some functionality, where do we want to perform some activity or functionality at the start, at the birth of the object, in that cases we will use the constructor. So definitely we need over here one constructor. As the object is created, then this value should be incremented. For that, I use a constructor over here, and the constructor should be counter, and in that counter we need one function, and in that counter function what I'm going to do, I just count and I increment the count. Okay, now you can see that when the C1 object is created, what it will do, it will create automatically call the counter function. As you can see over here, that we have written the counter function, the initializer, constructor will be automatically called, and in that constructor body we are incrementing the count, and count will be incremented over here at the shared space. Okay, so let's check whether it is working or not, just its behavior, because we haven't yet showed the value. So at that time there is no error. Now with the C1 I show the value. We also have the show function here, you can see. So the show will be used to show the value. Let's check its behavior, and now you can see that the users are online users are 1. So let's do another thing. We create a number of users. The number of users visiting the website is increasing, and we check the behavior that either every person is getting the same counter or not. So here I create number of counter. For example, this is a counter, or you can say this is a second object, and this is the third one. This is the fourth one. And this is the fifth one. So now we have created 5 different objects, means that there are 5 different users. Now every user, every individual should increment that value, and they should get the share value of that count. So let's see. That you can see that because we are calling the function after the object is created. So when the object 1 was created, the users were 1, 2 was created, then the users were 3. So it is correctly working, but the series shows that we are actually calling that here. So first we will create the objects, and after that we will call them to show that either it is working correctly or not. So first I will create the object, then we will check it's working. So now the program will work like that, first the objects will be created, the object 1 is created, the object 2, 3 are also being created. If the object 4, third one and fourth one, and that one is the fifth one. So 5 objects are created, and for that later on we individually called the show function. And now because 5 objects are created and they have already called the counter function, and in the counter function we have incremented the count from 0 to further, so it is already incremented. Now the every object now will show the 5 because there are currently 5 constructors. So you can see over here that there are 5 constructor, there are 5 visitors, and this is the value which is shared with everyone. So object is not going to have that data. Currently object is not having that counter. This is a shared value, this is a class level value which is being populated, and definitely by using the shared value we can save the space, we can save the memory and performance of the system. So this was the static. Hopefully you will get the idea that what actually static means and why do we use that. Let's recap, review the static, that how actually static data member works. For example, you have created one website, and for that website, this is an online website, and this is visited by a number of users. Every time when the visitor visit that, they we showed them one label that how many users are online. For example, currently 1000 users are online, then we are showing them to all of them that 1000 users are online. So what actually happened for that, in that case, the online user is a part of the object, and when every object is created, every object also has the same value, though the value is same. The counter 1, the user 1 value is 1000, the user 2 value is 1000, the 3 users values of 1000, and if there are millions of users, definitely their value will be 1000. All that is needing a separate space with every object. A separate space means that our program will need a lot of memory, it will need a lot of space to process for that. So instead of going to with that idea, providing a space, putting them as an object part, what we can do that having some separate, having some you can say shared space for that counter. So in here you can see that instead of placing the same static data members to the every object, what we are doing, we are creating a shared space. For that shared space will be a class part, this will not be an object part, because this is not an object part, so it will not be repeated as we repeat the object. So data is stored in one place, and every object is getting that data. Data is stored in one place, and definitely this will optimally use the memory. This will save our memory, and definitely our program will perform better comparative to the earlier one if we don't use the static data member. So thank you so much for watching, and I think this is enough for today.